And then we have this function to check the collisions. Check the collision. For example, here I will draw some other pipes or ducts or cable trees like this. Draw some pipes. And here, for example, I draw a pipe here and make a little higher. This one is 3, 2, 0. Yeah, so I create a collision here, right? And I can also copy or duplicate this one like this, make some collisions. And I can also draw a cable tree at this elevation and create another collision here. Middle one. This. Yep, create some collisions here, right? So in the real project, we will have a lot of collisions like this, right? Maybe thousands, not only hundreds, but thousands collisions. So here we provide two functions. First one is collision detective or clash check. In order to find all of these kind of collisions. So that is the first one. The other one is crossing in order to fix these collisions. So we provide two functions here. So you can find them from here. First, we try to find clashes here. So we will use the function in the tab of MagiCAD Common. Here is the clash setting, and another one is clash checking. Clash setting is used to define which discipline you want to check clashes. Here, we run clash setting first. And here you can see we have two selections. Selection A is only for MEP disciplines, ventilation, piping, electrical. We have only have this MEP disciplines. On the selection B is MEP disciplines and also architectural structure. Okay, so if you choose, so you need to select A, click some, and selection B, click others. For example, I want to check clashes between ventilation, piping, electrical. Then I should do like this. Selection A is ventilation, selection B is ventilation, piping, electrical, something like this. Yeah, you should choose both of them. So that is the clash setting. Just define the disciplines and OK. And then we run clash checking. Here is clash checking. And two options. One is for the report. At this moment, we use create a new report. At this moment, we use this one, create a new report. And for the range, because it's a small project, not a huge real project, so we can use this one, current view, in order to check collisions in the current view, not for the certain area. So like this, and OK. And then we will get this report, clash report. Then we find those clashes. But with Plain Rabbit, you should do that inside Navisworks, right? Yeah, with Navisworks, with Plain Rabbit. And then you should export an XML file, and then you locate those elements, right? But with MagiCAD, you can stay with this dialog. Please do not close this dialog. Okay, as I mentioned, please, at this moment, please do not close the report dialog because we will use it at least for 3 functions. Okay, so here first we find some clashes, right? And in this dialog, we also provide some similar view as Navisworks, for example, like this one. You can check in the right part is view. It's like a screenshot of this part. But not only the screenshot. Here, if you check the components tab, then we have this show function in order to locate related elements in the current view. So that means you do not need to locate the elements with element ID as Navisworks, because with Navisworks you can just export a report and locate them manually with element ID. But with MagiCAD, we can just click this button to locate in the current view directly. Okay, so for example, I want to know where is this clash. Okay, then I locate. It will locate. It will select it, the related element automatically. Then you can know where I need to fix the problem. Okay, so that is the first one to locate the clash. Okay, then the second one is how to export this report. Because here we have an export all function here. Export all. It means we can export a clash report directly. Here we can export the report with BCF file, like a PDF file directly. Yeah, we can export this report. For example, I can export a PDF file like this, find somewhere to save it, name it, okay, and wait a second, get this report. Maybe a little similar like Navisworks, but we have other functions later, okay. And then we already locate this clash, right? And here, maybe we need to find other clashes. Maybe for this one. The second one, okay. I find here is the clash. I want to fix it. Usually we fix the problem in the plan view, not in the 3D view, right? Okay, from the 2D view, plan view, we have this function crossing, this one. Vertical crossing. In the tab of MagiCAD ventilation, we have this crossing. We can use this vertical crossing, and you just need to define the start point and the end point. Because when you make a crossing, it's like a part or piece of the segment. So you need to define start point, the end point, and change the elevation of the middle part, right? So we define the start point, the end point, and then there will be an alignment dialog. It means you should define the elevation. It's like a bottom of or top of the reference one. Because it's a crossing, you should go above or down with the reference one, right? So here is the alignment. For the first one, it means go above, top of the reference one. For the last one means downstairs. So bottom of, yeah. So at this moment, I can just like this one to top off, and then click the reference element. Because if there is a clash, then there are two elements, right? One is the element you want to make a crossing, then the other one is a reference one. So when you select the start point, the end point, it is based on the crossing one, and another one is the reference one. So I select the pi start point, end point, then the reference one should be the duct, right? I take the duct as a reference and then check the result in the 3D view. We got this crossing. And it's just like a preview. We also can define something here and check the result of the preview dialog like this. Preview dialog. For example, you can define the angle of band. You can define the elevation here. And even you can save some tolerance between them. Because in the real project, you cannot make the elements close to each other. You should have a tolerance between them, right? So here, for example, for this one, I want to have like a 50 millimeters as a tolerance after crossing. And update here. If you change value here, then you need to update. Okay, update and check the result in the preview like this. So we fix the collision and we save a tolerance between them in one time. Okay, and I can also, for example, I want to use 60 degrees. Okay, that is the definition for the band. Okay, if everything is okay, accept it. Okay, then we create this crossing, right? fixes the problem. After that, I cancel the function and then go back to this clash report. I didn't close it. So I recommended that please do not close this dialog, because here is a function, is update clashes. You can find it from the report dialog on the right corner. It's update clashes, and if you run update clashes after you cancel the crossing function, okay, and here check the result. New clash 3 solved 1. It's like an update report. And you can also check the status in the report. Here is new clash, and this one is solved. Sorry, this one is solved. So you can update the report with this function. So that is why do not close the dialog, because we have this function locate, update, export, right? And we also have another function to fix clashes in one time for different segments if they are parallel with each other. For example, like this situation, like this case, I have 2 pipes and 1 cable tray segment, and they are parallel, right? And if I want to fix collisions for them, we have this kind of multi-vertical crossing. Multi-vertical crossing. And you can use this function like this, multi-vertical crossing, and similar options, start point, end point. And then if you do not know what is the next step, you can check instruction here. Select other segments where multi-crossing stand. It means I just define the reference one. I want to make a crossing, and which are the segments you want to have the same crossing. Okay, so I pick up like this pipe and the cable tree. I select all of them and then finish, and then still above or bottom of, right? Top of or bottom of. For example, I want to bottom off the reference duct, and then check the result in the preview like this. Pipe, cable tree, make a crossing in one time, right? And change some settings here and click OK and get the result in the 3D view, right? And if I cancel the crossing function again and update the clashes, and all of clashes solved. That is our function to check clashes, fix clashes, get a report, update the report.